And so the job of the algorithm is to come up with a feature vector, maybe A3 here, to represent the meaning of the phrase. So let me illustrate what we want. This is an illustration, so this is aspiration. This is what we'd like to do, not saying it. What we'd like to do is have an algorithm come up with a representation for the phrase, the day after my birthday. That is, let's say 3-5, that would that there. But it's going to be similar to Monday and Tuesday. And given a phrase like the country of my birth, you'll hopefully learn a future representation. Guarantee that will be close to Britain and France, because the country of my birth is something that's similar to Britain and France. So how do you do this? How do you come up with that mathematical? So I'm going to color in some of these ways just for the purpose of illustration. And the way we're going to learn these representations for phrases is we're going to use a neural network. So we're going to build a neural network that takes as input the two children nodes, so the V3 and the A5. And it's the job of the neural network to output two things. First, it should output a yes or no to tell us whether or not those two children should have a common parent. In this case, the answer is yes. And those two nodes should have a common parent because that is a valid phrase. And second, the neural network has to output a semantic representation, has to output a feature representation you want to use to represent this phrase. So, having trained the neural network, if you're given a new English sentence, you can apply the neural network here and ask, is the cat a phrase? The answer is yes. And the representation of the phrase the cat is going to be rectified to. Is cat sat a phrase in this class tree? The answer is no. Is sat on the phrase? No. No, and the that is a phrase yes, and the representation of that phrase is PV. You can then build up the representations, one layer representation like so, and now you can apply your neural network. The cat sat is not a phrase, and so the sat on is not, the complement is with representation A3, so you can now build up your representation, and so on until you build a representation for all of the nodes in the class. I drew this illustration, I did this animation as though we make these decisions usually from the bottom up. For those of you that are familiar with pauses, you can actually use dynamic coding to find you can pop down the bottom up so the pause is So now what we have is for every word, every phrase, and for the entire sentence, we can come up with a feature vector to represent the semantics or the meaning of that English phrase. And so what we did was, to try to figure out if these representations are useful, what we did was we took a sentence, which we call the center sentence, and we computed the feature representation for this center sentence. Both took parentheses yesterday. We computed the feature for that. And what we did was we looked through our corpus, looked through our set of English sentences, and we found the sentences with the closest feature with the most similar feature representation as the center sentence. And we list on the right the 4 feature vectors with the most similar feature representations. So the other things that most similar to both of parentheses yesterday is we look for a lot of turbulence, so on.